Hi, this is Maggie. In this video we're going to talk about checking boundaries when we have an object that appears to be moving within our game window. By checking boundaries we can give our object the behavior that we want, such as bouncing, wrapping, or stopping. Here is figure 9.1 from the text, which shows the coordinate system of a 480 by 480 pygame window. And superimposed over that image, I have the ball image from listing 9.1. Let's suppose that we want to move the ball within the window, but we want it to stop when it reaches a boundary. Let's think first about how we would keep the ball within the window if the ball were moving left to right. Here is a program called blitting practice, which blits a ball to an x coordinate that increases by 5 pixels each time through the game loop. If we run it, we can see our ball moving across the screen from left to right. There's no boundary checking in this program, so once the ball reaches the right side of the screen, it keeps going, and we lose sight of it because it's being blitted off screen to larger and larger x coordinates. Returning to our graphic, let's work out what's happening. We're blitting the ball to increasing values of x. So for example, x equals 5, x equals 10, x equals 15, and once we reach x equals 480, our ball is no longer visible because the right side of the screen is our ball's left coordinate. We will need to check if we are about to blit the ball so that part of it is no longer visible, and stop changing the x coordinate if we want it to appear to stop within the window. So the question becomes, how do we know from the information that we have that the ball is about to be blitted so that part of it is no longer visible? What does that look like? Well, we start the ball over at x equals 0, and we add 5 to its x coordinate and blit it each time through the game loop. At some point, we add 5, and our x value is still within the window, but the right side of the ball is not. At that point, our x coordinate plus the width of the ball, which is the coordinate of the right side of the ball, is greater than 480. So that is the check that we write. Let's go back to our program and change the name to boundarycheck.py. So we have a new version of the program for this new functionality. Our ball is 71 pixels wide. So we could write, after we adjust x by adding 5, if x plus 71 is greater than 480, then x minus equals 5. So subtract that 5 that we just added. Let's run that and see what happens. Okay, and it stops at the right edge of the screen, so that's great, but it's a little rough around the edges. First of all, the ball doesn't stop exactly at the edge, it stops before the edge. That's because our ball wasn't 5 pixels over the edge, so when we subtracted 5, it wasn't exactly at the edge. It's within 4 pixels of the edge. We can fix that by setting x to exactly 480 minus 71, or the right edge minus the width of the ball, or 409. Let's see how that looks. Okay, and it appears to stop right up against the edge. But there are still two problems. One is all of these magic numbers. 480, 71, 409. Are we going to remember what those mean in a few months if we come back to this program? Are we going to remember tomorrow? And what if we decide to change the size of the window or the ball image? Let me resize the window and illustrate how that breaks our program. I'll set it to 480 by 640. Okay, and I do that by changing this make window function to take two parameters, width and height. And I set two constants in the main program. One for width and one for height, and I can pass those into make window. And I'd better change the background too. And I run my program, and it looks very silly because the ball stops at 480. A much better way to do this is to get the width and the height of a surface from the surface. It will make the code easier to read, and it will prevent it from breaking if any of the surface objects are resized. So, for example, if we used a different ball image, or if we resized the window, as I just did. I'm going to rewrite the code using the surface methods getWidth and getHeight. So if we look at the line, if x plus 71 is greater than 480, what we're asking is x plus the width of the ball, the image we're blitting, greater than the width of the screen? That looks like if x plus ball dot get width is greater than screen dot get width. And then inside the if statement, if it's true, we want to set the right side of the image to the screen width, but x is the left side of the image. So it's screen.getWidth minus ball.getWidth. And when we run the program, that works perfectly. The ball moves across the screen and stops at the right boundary. If I change the ball image that I load or resize the window, that code will still work. Now, one other thing is that maybe we'd like to make that check before we change the x coordinate in the first place. Or maybe we'd like to set a Boolean flag called moving to true or false so that we don't keep adding 5 to the x coordinate and then setting it back to the edge of the screen. Maybe we only change x if we aren't too close to the boundary. I'm going to leave that for you to figure out because it will be a good exercise to help you confirm how well you understand this. Let's briefly talk about the other 3 boundaries and ways we can change the ball's motion that are different from stopping the ball. The bottom boundary is similar to the right boundary. We must find the y coordinate that is the last coordinate at which the entire ball is visible, which is the window's height minus the ball's height. For the left and top, it's a little easier. The ball is still visible when blitted to 0, 0, but will start to disappear at negative coordinates. So you can check for x or y less than 0 and simply set x and y equal to 0 to stop the ball at the left or top boundary. To check for all 4 boundaries, you must check that the ball isn't off the left or off the right, and separately you must check that the ball isn't off the top or off the bottom. Of course, it can't be simultaneously off the left side and off the right side, so you can use an if-else statement to check those boundaries together. In other words, the value of x being less than 0 or x being greater than the width of the screen are mutually exclusive. However, both x and y could be out of bounds, so you must check x and y separately. Now suppose we don't want the ball to just stop. Suppose we want it to bounce or move in the opposite direction once it reaches a wall. We can work with our program and change it so that the ball bounces at the right boundary. Now, if you know how to make the ball move right to left, you know that we subtract a value from the x coordinate to simulate that motion. So once we've reached the right boundary, we want to start subtracting, in our case 5, rather than adding it. One way to do that is to create a variable called dx, which will mean the change in x each time through the loop. I will set dx to positive 5 before the game loop. Down in the game loop, I'll add dx to x instead of hard-coding the 5. Now, when we check the boundary and find that the ball has reached the edge of the window, we can multiply dx by -1. That turns it into -5. And so the next time through the loop, the ball will move toward the left edge of the screen. We still set x so that the ball appears to bounce off the edge of the screen before it begins moving in the opposite direction the next time through the loop. Now, if you've modified your code to perform the check before changing x, your code will look a little different. However you write it, make sure the ball appears to touch the wall before you start it moving in the other direction, or it won't appear to bounce. You don't want to change the direction and also move it in the same iteration of the game loop. And we can run that. And wait for it to reach the edge, and then it appears to touch the edge and move in the other direction. Now, what I will leave to you is then checking that it bounces on the left edge and changes its direction when it reaches the left edge. I will also leave you to implement similar code for bouncing top to bottom. Suppose we want the ball to wrap around when it reaches the edge. Then we can set its location to 0 when it reaches the right edge. Let's implement that. I'll comment out the other code and write new code to wrap the ball. What would look best now is if we let it disappear completely off the screen and then reappear on the other side. So I'm going to check for x greater than or equal to the size of the screen. And once it is, I'll set x equal to, well, think about that for a moment. If I set it equal to 0, the ball will appear to materialize on the left side. It will be better if the ball moves in from the left. So I'll set x to negative the width of the ball. And if we run that, we can see the ball appears to wrap around the screen. Experiment with this code. Write similar code for the ball wrapping bottom to top. And once you have all of the variations working and you're confident you can write boundary checking code that handles boundaries by stopping, wrapping, and bouncing, then you're ready to move on.